How's it going, everyone? Eulier again. Looking now at NeetCode problem solution, which is a series of courses and exercise from LeetCode from Navdeep Singh. So he's a software engineer that joined as where he worked at AWS, and now he found his own way of learning that. He also works at software engineering intern, software engineer at Google and Capital One. He also now is the founder of NeetCode. This way of how you can now is learn the fundamentals of not only resolving LeetCode problems or passing this interview question, is also understanding what is the practice, what is the techniques that allow you to, when it comes to solve common problems, use common data structure and algorithm to come up with that. So initially, all right, we're only going to take a look at this arrays and how from arrays you can now have algorithms or way techniques to solve problems like two-pointer and stacks, followed by the binary search from two pointers and sliding window and linked list. Okay, and how now when you combine the binary search and the linked list, it actually leads you to give you ability to build a trees, and how from trees you can have tries, heap priority queues, and backtracking. And as you can see how all of this actually lead to that. So the idea of this is that looking at this programming concept, whether it's the data structures and algorithm, data structure like arrays and hash, stacks, as well as linked lists, trees, graph, priority queue, and then how you can now is specific algorithms that allow you to come up with some way to solve common problems. And I think one of the beautiful thing of this is that you can now see what is the common pattern that they're using, especially when they need to come up with some problems. It's like, hey, how is this thing is gonna represent? What is the representation of this theme? And I think that's quite beautiful. Totally, 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 totally. Uh, so we started. The methodology here is we're gonna dedicate 45 minutes daily as a way to the first 10 minutes is to see how can we solve this particular issue. If we can, then take a look at the solution. All right. And even though if we weren't able to, or if I weren't able to solve that, no problem. But I'm gonna take note of that. So initially we start with arrays and hashing. So hey, how you can now solve this contain duplicates? Pretty straightforward. We use here is a set for that as a way to now give me only these unique values, okay? Or in the case of JavaScript, because at the end of the day, that's the reason why we're using this with TypeScript, all right? Is that, hey, how can we now is organize or how can we identify if two elements at least appear twice, okay? If that contains duplicates. So one way to solve that is, well, by now setting a flat, iterate that using the iterator protocol, or this iterative protocol, which is now is built in on the language, the JavaScript, and how by using a set we can now is hold unique values, and we're gonna add all of this values to that. All right, if that value exists, if we already have that value registered, it means that this collection already contains duplicate. Therefore, break. Say, hey, yeah, it contains duplicate. Again, pretty simple, straightforward, easy to solve, easy to fix. Then we look at valid anagram. Again, all of this is working with collection of elements, collection of numbers. Then we look at how can we now is work with collections of strings. Okay, what is the valid anagram here? And I think that's quite interesting because after all, an anagram is a word that it can that when you rearrange the letters is exactly the same one. All right. So, for example, anagram and nadagram. Okay. So, an anagram is a word or phrase formed by rearranging the letters of different words or phrase, typically using original letters exactly one. So, a valid anagram is a word anagram and nadagram. Okay, exactly. If the words can be now right backward and forward, right? Is a word or phrase formed by rearranging the letters of a different word or phrase, typically used in an anagram. Exactly. So by rearranging the word of that, it gives you a nam aran. Okay. By rearranging the word, which is an Easter egg suggestion in Google, after searching the word anagram. After searching the word anagram. But I don't think they actually give that any longer. Nang arak. The original word or phrase is known as the subject of the anagram. Any word or phrase that exactly reproduces the letter in another order is an anagram. Someone who creates anagrams may be called an anagramist. But in any case, the idea here is that giving a word, okay, in this case, is an anagram is a word or phrase formed by rearranging the letters in a different word or phrase. So you can create with the same. So an anagram is a word or phrase that formed by rearranging the letter of a different word or phrase. So you can create, given the same word or phrase, create a new word or create a different word or phrase. So far so good. So the way of how you can now check if that is true is by saying, give me these two elements, okay, this valid anagram. Let me actually sort them using the UTF-16 NeetCode, where now I'm going to organize all of those letters in a lowercase. Okay, so first let me transform each one of those strings into a lowercase. Why is that? Because once you have those lowercase, you want to transform that into an array where you want to convert, where you want to sort them using the UTF-16 NeetCode, which is now is a table that actually is going to organize letters in that order. It's going to sort in that order, okay? And then I want you to give me is the string from that. And I'm going to compare that, right? So if that string is the same as the target, then it is a match using the object.is for that. And I think this is quite interesting and quite compelling for that. And also, this is a very good way of how you can now work with collections of number, collections of strings, and also uh, with this challenge here called the two sum. Two sum and group anagram. So with two sum here, uh, the idea is to identify what is the index of two numbers, and if those two numbers exist, which you, yeah, what is the index of two numbers? So when you add them, it will give you the target. Okay, so with this, now you are is combining is data structure like arrays and hash. Okay, how so? In this particular case, we only have is one exact. We have exactly one solution, which is great, part of that constraint. So what we're gonna do is to now store in our hash. Okay, the key will be is the value, and the value will be the index. So anytime we want to actually is look at the difference of look at the difference to see if that actually exists in our map, we can actually know which index belong. And that's something beautiful. Why is that? Because this is the way of how now the vast majority of computer science and problems in that is about representation. Similar when we have is React, where in React I say, okay, now I need you to is represent this UI state change using state. All right, this representation, especially when you're going to build now a React application or think in the React way, you need to have is the mock, the data, break down the UI into several components, so you can create this component hierarchy, and then you want to is set a static version of that, followed by the followed by the followed by the find the minimal but complete representation of your UI state change. Okay, and this is now what you can see is this representation. Again, I know I am a bit Jesus. I know I am a bit of a abstract here, especially because when you are now creating is this UI. Okay, but the entire idea of this is that it is important to build is this user interface, this user representation of that. So that's quite interesting. That's pretty powerful as well, because now once we are looking at this, and there is another challenge that I want to mention, which is group anagram. The idea here is that, especially with the two sum, is to say, hey, give me now the index of the two number, such as they add up to the target. Okay, so here's when you can now is work with the hash and the index. Remember the structure of the hash and the index. In the case of the hash, you have keys and values, and in the case of array, you have is the index and the value. Okay, and how you can now work with that. All right. So in the case of the two sums, you say, hey, if I need to actually need to know which of those two index, which two numbers such as their index, so which of two numbers such as they add up to the target, okay, provide me is the index. So here is they actually telling you what you should store here. So in your hash map, we're gonna now is use this particularly we're gonna use is the keys as the values, okay, and the values as our index from this array. And we're going to iterate through that array, okay? And anytime we iterate through that, we're going to check if the current value and the difference with that value exists in our hash. If that doesn't exist, that's going to add that. If that exists, good. Now it is time to return that. This was quite interesting, similar to the group anagram, where now in the group anagram we do something fairly common, or fairly, yeah, they would, because with that, with the group anagrams, after all, they give you now a string, okay, and they tell you, it's like, hey, group the anagrams together, okay. So here you're gonna have a map, okay, unlike the 2 points, or like the 2 sums, when you have now a collections of numbers and you want to figuring out which one of those 2 numbers actually add up to the target and give me the index, give me the position, all right? So you can do whatever you want, or the thing that you need to. Now with the group anagrams, we're gonna have is our map, okay? You can see when you need to group things, when you need to group things using a collection, one of the great things is using a hash map for that. Pretty straightforward, right? So with our hash, what we're going to store is as the key the sorted element, or the sorted word, okay, and as the value all the elements that actually are the same as that sorted word, which is we're going to store them into an array. And that's pretty much. And then we're going to return that's it. So here we're using is now the iterative protocol, or the iterator protocol, as a way to now, instead of actually us having to define in an imperative way using the for loop, we're going to use now this iterator pattern, which is the way of how we can now traverse a data structure regardless of its implementation, okay? And I think that's something beautiful, this design pattern. So anytime now the for of syntax call that iterable, okay, you're going to get is inside of the block each one of those elements, okay. You're gonna get that element and the next one and the next one and the next one. I also look at how can we implement that using closures, and how now by storing is the index in that you actually need to have a careful, so you need to be, it requires careful programming. That's what happened. It requires careful programming when it comes to it requires careful programming like that. It require careful programming, because now you need to keep track of the index as well as the thing that you're returning. So with the iterative protocol, which is made of the iterable part, which is the behavior or the custom logic that you want to now you can provide or customize as the iterative algorithm. When you use for loop, or when you use for of syntax, you're gonna get that element thanks to the iterator protocol, where now is the way of how they're going to produce sequence of data anytime you call this function, okay, this iterative algorithm. And the follow is the shape of next, which is this function that it returns is the value of done and the value, all right? And also it returns some other optional properties, but the key here is the value, okay? So with that, that's exactly what we did here. So I want you to iterate through this collection of values, and in this case, all of these words. I want to get that word sorted, all right? I want to get that word sorted, and then we're going to now compare if the sorted word that we get that exists in our map as a key. If it exists, all right. Now let me actually add that word to the value. If it's not, then let me now create an empty array for that. So we can actually, the next time is to add that element to that. So that's quite interesting. That's very, very, very interesting. Very, very, very interesting. Totally. I must admit. So the worst case here is actually m power m. Why is that? Because we have to iterate through all of these elements here, and then we actually now iterate through all of this word, okay, as a way to sort them, right? So, but again, this sort method here, I think there is some quite convenient approach here to do that in the case of group anagram. If we take a look at the LeetCode here. No, wait, what? No, good for you. Group anagram. Do some. That's right. You got now this. Do some backwards. Group anagrams. That's quite interesting. Okay. This one. Yeah, just want to take a look now at the group anagram. I never saw the solution here.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's look at a good question to practice the fundamentals, group anagrams. So we're given just a list of strings, and the second one strings, so these two are the strings, and we have to do that m times, where let's say m is the. So my question is, can we do better than this? And actually, the simple solution in this case happens to be more efficient, and let me show you that solution right now. So one also condition that we're given is that each character is going to be from lowercase a to lowercase z. So at most, we have 26 unique characters, right? A, and it has one T. And for this one, we would see that the exact same thing is true. It has one E, one A, and one T. So if we use a data structure called a hash map in this case, and in this case, our key is going to be this over here. So this is what we can use to identify anagrams, and then our value is going to be the list of anagrams. So in this case, how many strings or which strings have this pattern of count 1E, 1A, and 1T? Well, we see there's one eat, there's one T, and there's one last one 8. So those are going to be the values. We'll have a list of them, eat, T, and then 8, right? So we'll have 3 strings, and as you can see in the output, it's a little messy, but that's what we have here, right? So these 3 are grouped together. So we're going to use a hash map to group them together. Since we're using a hash map and all we're doing is counting the characters of each, and we know that we have a limit of 26 lowercase characters. The overall time complexity is going to be big O of M, where M is the total number of input strings that were given, times N, where N is the average length of a string, because we have to count how many of each character it has, so we're gonna have to go through every single.
Which is pretty much what we did exactly with our group anagram solution. All right, so that's actually pretty much the same. But the point of this is that, or the reflection is that, now that you have this collection of values, okay, which is an string, how you can now group them together, how you can group now anagram together, and not only that, how you can also, especially how you can group now brands together, okay, for example, shoe brands, cars, that kind of thing, how you can actually do that. And I must say that this is one of the way of how you can practice the fundamentals of hash and arrays. And to me, that's quite interesting. So, the other is a top k frequent elements. So, by reading this top k frequent element here, from here, okay. So, because before of that we have a particular approach, but that approach actually doesn't work as expected because we didn't understand the problem. Okay, but now we do, and that is, given an integer array nums and an integer k, return the k most frequent element in the array, which means that if you have an array, give me is those numbers that are more frequent, give me those numbers that are the most frequent given this number, you know. So because after all, here we are counting elements, okay, one of the naive approach will be is let me count, let me traverse the entire string, the entire collections, okay, and on each one of those elements I'm gonna ask, hey, is this value existing in our table, in our map? Okay, no, please add it and put it 0. Okay, if this element actually exists, okay, let me now add 1 to that. So this is the way how you can count all of this number. Okay, so you have now a table where the key will be is the value and the value will be is the count. So far so good. Okay, but we want to know is which one of those elements here, okay, we want to know which of those elements here actually are the most frequent, okay, giving a k target. So as you can see here, we receive all of this collection of value. We're now transforming into a hash as a way to now have them in an organized place counted, okay. But given these values and the keys here, okay, we want to know is which one of them actually has the most which one of those elements are the most frequent elements. So because we store our hash with the key as the number and the with the key as a number and the value as our with the key as the number and the value as the count. All right, we have that representation. Now we need is to actually somehow find a way to get that. To get is those that satisfy is the k. Hey, is this number actually is greater than the k times? Okay. If it is, all right. So you may return the answer in any order. So return the k most frequent elements. After all, you need to return, so you need to actually, is given that hash that you have, okay, you need to somehow transform into an array, because you want to know from all of these numbers that you have, or from all of those sequence of numbers that you have, you want to know those who actually is the most frequent. So once you have now this hash, then you want to create perhaps an array that will hold in their key, okay, their key will have now is their key will now have is the value, okay, and the value, and the other is the key will be the value, okay, and the key will be the value, and the value will have is now an array of those numbers that match that count. In other words, you're going to have is that index sequence will, okay, that index sequence will represent is the counted values. All right, the counted values, and their values will represent is now those elements that actually now, those counted elements. You know what I mean? Because at the end of the day, you want to know the k most frequent element. Let me actually transform it. We need to count the number of times and a number is on the number array, and then somehow only return an array those numbers whose counters are greater or equal than that. That might be one particular approach, okay? So first we need to actually count our numbers. As a way to now is the occurrence. Okay, define an array to push all the k match numbers and iterate through the array. Okay, let's check if the number exists in our hash. If not, add it the value of 0. If it is, add the value plus 1. So far what we did is just to check that. Okay, so define a hash to count our numbers occurring. Define an array of So here we're gonna say is define a hash to count our numbers occurrence. Okay, so this is the map that we're gonna have is the counter occurrence. Okay, the key that represent key as the value. Okay, that represent key as a value. Okay, and value as the counter. So far so good. That's the only thing. That's what we're gonna do, right? Define a hash count to count our numbers occurring. Okay, that represents key as the values and value as a counter. All right. It's going to iterate through that array to populate our hash counter. Okay, so if that number exists in our hash, okay, which is this. So if that number doesn't exist in our hash, add it with the value of 0. we're adding with the value of 1 because now we count them 1. If it is, add the value plus 1. Exactly, add the current value plus 1. And all of this is just to, okay, all of this is just to count, okay, all of this is just to count count occurrence in a map. Okay, count occurrence in a map. So now that we have those occurring in our map, okay, which is great, then somehow I need is to actually return is what are the most frequent elements k. So one way to represent that is by saying something like this. Now that you have an array, okay, which is k most frequent array. Now that you have an array, okay, that will allow us is to represent, okay, that represent is the key or the index as our number, okay, the key as the number of occurrence, okay, the index as the number of occurrence, and the index as the number of occurrence, and the value as an array of numbers. Yes, an array of numbers. Yeah, and value as an array of numbers that match. Yeah, and values an array of numbers as an array of match occurrence index number. Right? That's the whole point of this. Okay. How can we do that, you might wonder? Because after all, we have is our numbers as an array. We got our numbers as an array, this array of numbers that we're receiving. We got our numbers as an array, and we also have a map here. So our array, the array that we're receiving, the number array that we're receiving contains all of these values. Some of them contain this more repeated number and that kind of thing or not. Okay. And we also have is the map here already stored. So our map has this count the occurrence in a map. Okay. So the idea here is that we can say is that how many times here, so somehow we will need to iterate through our map. Okay, so how many times when we iterate through the values, okay, we'll need to iterate through the values of our map and somehow store, okay, and somehow is stored at that position in our yeah, at that position. So the idea will be is this. because we will need is to the k-most frequent array that represent index as our number of occurrence values array of occurring match. Now we're gonna do like this. We're going to iterate through the count occurrence or the counter occurrence, exactly, counter occurrence map. Okay, we want to get is their values that will contain is the counter. Iterate through the counter occurrence map values. Okay, and let's go to assign exactly, and let's go to assign now is and now let's go to assign is okay, and now let's go to assign is this. Exactly, and now let's go to assign is this, and then assign to an index, assign to k, assign to k-most array index the values, okay, and assign their values, okay, and assign to k-most array values an array of values from the the values of keys. The function has to count our numbers occurring that represents key as the value. In this case, is the value of the number. So with this algorithm, now that we have our collections where the index will contain is the counted occurrence, okay, which is counted occurrence, okay, counted occurrence, and here the array will contain is now the yeah, this is the counted occurrence, and the array here will contain is the array of numbers, okay, that occur that. So that's exactly what we're going to do here, and that's quite interesting because now when we get this k, okay, because we store that, then finally we will able is to say, hey, I want you to give me is the for example here, and now is access to the k most frequent, and access to the k most frequent, or return, then say return, and return the k most frequent, the k most, yeah, return the k most frequent numbers given a k value. So this is now the series of sequence and step that you're going to apply to your life as it is, right? Um, yeah, totally. Yeah, totally. Yeah, totally. Okay. So now that you know what you're gonna do, okay. Uh, all right. So what I just want to recap here. We are using is now data structure like hash, an array, as a way to now represent what are they going to represent there. And then the entire reason of this is to get that element fast, get that element quickly. So of course this is quite what you can expect here. Might be quite okay. So here we define is the counter occurrences. We can say, hey, this is the dictionary or counter occurrence, okay, as well as the matches as an array. And here, because we're iterating through this, we're saying, hey, is the counter occurrence like this, where now the key will be the number. Okay, hey, if that number doesn't exist, please add it and put a 1 for that, because we're starting to count that to the counter occurrence set. Okay, uh, otherwise, if that exists, all right, otherwise that exists, let's go to update that, period. So far so good. So this is the logic for uh, update update our update or counter currency, update or counter of the counter occurrence. Okay, update or populate here is this. This is populate populate the counter's occurrence. Okay, populate the counter occurrence. So far so good, no problem with that. Then and if you can take a look at that, what you have here you should is now return is those counter occurrence, which is in the first case. Oh, counter occurrence here. That's right. That's right. Where the initial input. Okay. Oh, okay. Any. Where now the initial input here is this. Exactly. Let last executed input like this. But say, hey, oh, I think it's because you might not be valid that. No, wait a single moment. Wait. Open test case. Exactly. Exactly. It's like this. So you just want this to return is this, right? Counter occurrence dot get and that kind of thing. It's not a valid expected return type integer. The question is that well, print that out. Exactly. 1 has 4, 2 has 3, and 3 have 2. Okay, no. 1 has 3, 2 has 2, and 3 have 1. Okay, if you detect that, it's going to put that 1. So if that doesn't exist, put that 1. And then you're going to update that value, right? Another way to put it is that say, hey, I'm going to add the else here. And this is also something that is going to work. Right? Then this actually worked as expected. So far so good, right? But without putting the if here, so what you essentially is now saying, hey, if that doesn't exist, exactly, if that doesn't exist, put it 0, and then it's going to update that. That's the logic here. So far we got is our map properly updated, right? We have the number and the occurrence. And then we need to OR now is iterate but is through the map. That's one of the reasons why this iterator approach of this iterator protocol that is part of the design pattern, okay? The iterator in TypeScript, this design pattern, and this is widely popular, and it's not that complex, but after all, is something that it allows you to, exactly, the iterator allows you to traverse through complex data structure without exposing it as internal detail. So thanks to the iterators, client can go over elements of different collection in a similar fashion using a single iterator interface. In other words, regardless how the data structure is represented, okay, whether it's an array or an object, a map, a linked list, double linked list, tree, try, graph, it's going to expose now this iterable as a way to have now a consistent way of accessing to this data by just running is a function. So for the client, it abstracts now how that thing is implemented, which at the end of the day, most of the time we care is just only to work with the data, period. That's what we only care about. So because of that, we need to actually iterate in our map, which is counter. We need to iterate through our map, and luckily for us, we don't need to use the object.assign or the kind of. Now, unlike objects in JavaScript, maps provide us this ability to iterate through that, which means is, well, I want you to now iterate through the counter occurrence, okay? And because this is a map, it's actually going to do that using the for, using now the for of syntax, where now here is when you're going to receive okay, where now here is when you're going to receive is this this key value pair. The key, where in our case will be the values, and the value which will be is the occurrence. Okay, and now we're going to say is this: how can you now in an array actually set an index and its value? Pretty simple. You can say matches using the square bracket notation. This will be your index occurrence. Okay, that'll be the that you're going to be assigned to the value. But because we need to find something interesting here, we need to check if that actually exists. So if matches occurrence here, that's right, matches occurrence exactly, matches occurrence. Anyway, so if that matches occurrence exists or does not exist, well, let me actually create that for us, which means that matches occurrence. Okay, if there is no any, if we don't have that, if we don't have any value there, well, let me now assign that value here, which will initially will be an array. Why an array? Because we can have as many occurrences here. Okay, and then we're going to actually update the value. Matches occurrence, so that'll be is this. So at that location, okay, I want you to now is push the value to there, or you can do something like this. I mean, sorry, something like this. So at that position, okay, I want you to now update the value. So as a way to actually check our logic here, counter occurrence. What is this counter occurrence? Oh, is this one? That's right. Counter occurrence is matches an occurrence. Oh, occurrence. Yeah, misspelled that. Yep, occurrence. Okay, now it's time to you to run. And I just wanted to look is the matches. It say matches. Oh my God, occurrence. There you go. All right. So here we gotta say, hey, one empty on the slot 1 we got 3 times. On the slot 2 we got is 1 time. Oh, I think I need to put this. Okay. There is no one element, and the number and the position 1 we got 3, so 1 repeats 3 times, so 2 repeats 2 times, and 3 repeats 1 time. And pretty much that's it. So what we're going to return is say, hey, well, given that k number, okay, given this k number, I would just want you to is matches dot k. That's all. So when you run this piece of code, all right, it say, hey, k is 2, expected 2. I'm sorry. I'm sorry. Exactly. I need to do is this. I need to. Okay. Sorry. I need you to return is the most frequent elements in that array. Okay. So I want you to provide me is those. Give me that array. Okay. Give me that array whose k are greater than this index. You know what I mean? In other words, matches dot filter. Okay. The first element is the value and the index, whose index. Okay, whose index is greater or equal to the k. So return me those elements that actually match that, which means is the occurrence, the values there. As you can see, you get that. The order doesn't matter here, the output here, but you get the idea. Populate the counter occurrence, and then you say populate the array of occurrence and matches. Populate the counter occurrence and populate the array of occurrence and matches. The occurrence as index and matches as values. Exactly. And then now you want is to return those values, or return those values return those values, or return the top k frequent elements. So even though that this code might be quite long and verbose, I must admit, it's one of the trade-offs, especially when you are writing your applications and your program, which means is, well, the three pillars of programming is speed, memory, and readability. Speed, memory, and readability. So I am quite amazed on how did I solve this. Okay, it's a, hey, you get a wrong answer. Why is that? Wrong answer. What? 6 of 21 intercase passes. Oh, do I need to check for? Yeah, do I need to check for? Okay. 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 So if the nums length is equal to 1, all right, then you're going to return is return k, or return that value, say nums of that position. Oh, I mean, is this one? Oh, chill. Oh, because you need to return is this as an array. Exactly, like this. Exactly, but when you submit that, it say, hey, there is a wrong case here. Okay. Mm-hmm. Okay. Case in the range of 1 and the number of unique elements in the array. It is guaranteed that the answer is unique. Alright. It is guaranteed that the answer is unique. That's interesting. Oh, I get it. And now it's because, okay, it's this condition. No, no, it's okay. It's this condition. Yeah. Return top k frequent elements. Okay. So we can say it matches like so. Okay. You got your map. Oh, of course. Now he's going to complain about that. Say, hey, what do you think you're doing? Find or filter whose value and index is the same as this. exactly, whose index is greater or equal to k. Mm-hmm. Okay. Well, actually, you should return that. Oh, not at all. It's because it's 0 and what? I get it. -1. It's because the position. It's because the position. It's because the position. Yeah. It's because the position. And this should work. Aquí vamos otra vez. Oh shit, here we go. y a tu salud brindaré. All right. So because in our map we had is this. Really? For real? Hmm. No, it's because of this logic. Because when you reach this, it say, hey, give me now the two most k elements there. And I'm comparing is that by their index. And that's not what it is. In fact, oh, okay. No, no, sorry, my bad, my bad. Is find that. Is find that element, in this case the value and the index, and find that at that index position, okay, find that whose index is the same as the k value, and that will contain all of the value at that k position, which is the k most, the most k element here. And 1 is 3, 2 is 2. Okay. Mm-hmm. Mm-hmm. Okay. Mm-hmm. 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 Mm. Mm-hmm. Because what I'm saying here is this. It's like, hey, yeah, try to find that, but in there, in that array, we should have all of these values. You know what I mean? Mm-hmm. So if we return is now the matches here, and only to give them those that exactly. Look at this. You need to do this. So one. So 3 is the number of occurrence. So this must be in the third position. Is 1. 2 must be in the 2 position, and 3 must be in the third position. So far, so good. but I want you to give me is the 2k most elements. So from that position and on, right? From that position and on. So return those, filter from that position and on. And only give the values, which is the value and the index, okay, from that position and on, whose key is equal to the index, or whose index is equal greater or equal from that index and on. Which means is that from the K2 most elements, which means is from the K2 most elements, it means that from the K2 most element, but then it say okay, it's because we will need to, okay, it's because we will need to order okay. So we will need to say okay, plus 1 as a way to say okay, because we couldn't because we're not counting it from this, not from the 0, but for plus 1 we say is the position, okay, in the array, or index array will be is now the occurrence plus 1. And now you will get is the proper values. Why is this? Because array starting from 0, and you mean, oh my god, because it's array starting from 0 and we want to start it from 1, and then is when we're going to count that element. But the case 2, okay, okay. But it's because how now we represent arrays in that arrays start with 0. That's what happened. So because array start with 0, unless we say something like this, but now it will say, it will look one further than. But because it's array starting from 0, we will need to say, hey, look now at the most k, at the elements on the left. That fucking hell. If on the position 2, and in your array you must have is another thing is to say provide is the last element here. Is to say, hey, I want you to give me is now, because now we have this collection. Okay, I want you to give me is the k most elements in that array. Okay, I want you to give me is the k most elements from the reverse order, which means is that sort them, all right, and then reverse, where now I have is the first elements there. So now exactly sort them by their index. Okay, when you have this 100 element here, perhaps with 0 and that kind of thing, and give me now the k most frequent element from that. Filter that by their then filter that by okay, and then okay, with a single mode, return the k most frequent elements. So give me now is an array here, on shift values with because now the representation here is the keys, the number of exactly the occurrence and the index. Occurring as the index and the matches as the value. You can splice this. Exactly, and then you can splice this. So what we're doing here is this. Because now this array is sorted, okay, and it is sorted based on the index as the number of occurrence, okay. So we're going to sort that based on the number of occurrence and reverse that to actually have the most elements, and then split that, splice here from that position to the position of that element, and that'll be all. And this is it. Um, slice, sorry, it's a slice. Exactly, it's a slice, sorry, it's a slice. Slice from 0 at that position. -1. Because at the end of the day, that's what it is. We're counting from 0. Exactly, it's matched sort by their numeric order. Okay, where now you have here is this representing is the matches, the index as matches, index as matches, index as matches. Okay, matches values 1 and the number of occurrence. Okay, so the position 1, the number of occurring of 1 is oh no. Mm-hmm. And then when we want to reverse, which is the thing that we want to, all right, mm. But I got all the matches here, okay, and if I sort them, so I got all the matches here, and if I sort them, I got this like that. So 1 exactly. So 1 times is is sorting is by its value, not by in. Okay, never mind. It's sorted by its value. Hell no. Reverse. Reverse. Exactly. Sorted by its value. Hell no. My bad. Okay. Reserve. Reverse. Okay. That's right. You got this reverse, and then you say, give me now those up to that position. Slide that into that position. So you're gonna get is the most k elements out of that. Mm-hmm. Okay, probability array of occurrence and index matches as values. Return top k frequent elements here. Mm-hmm. Exactly. And then you flat that, which is putting them into one single array. Mm-hmm. Okay. Result. Okay. Okay, that's right. Mm-hmm. Okay, because you can also receive is negative numbers here. Exactly. The numbers can be negative, which means you can have now an array of negative numbers and positive numbers. Okay. Okay. Mm-hmm. Mm-hmm. So for positive number, it works well. But when you have to combine now with negative number, because this logic actually is storing all of these elements properly, but the result here, this logic is when it's not working as expected. Because when you say, hey, let's go to reverse this, and by reverse is that, okay, mm-hmm. Mm-hmm.
Hey everyone, welcome back, and let's reverse exactly 3 times. So, or however we do it, we're only going to be doing values occur twice. A single occurs exactly once, so in that case we'll have all 6 values concentrated over here, and that's still going to be linear time because yes, we are going to be iterating through this entire input array, which is going to be big O of n, and then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So we are going to use a hash 0, so this will return 0 if it doesn't exist. 4. And so we're going to be iterating through this array, or it could have some values, whatever it does. So let's say n.
Exactly.
The last index, and we're going to go all the way up until 0, and we're going to be going in descending order. So we're going to put a -1 as the decrementer, and we're going to go through every value. So for every, let's say, n value, then we're going to go ahead and take that n value and append it to our result, because we're basically getting the n value that occurs most frequently. Now, when are we going to stop? At some point, our result output is going to be the exact same size as k, because we're guaranteed to have at least k values in our input array. So once that happens, if the length of result is matching exactly k, that's when we can go ahead and return result. We know this is guaranteed to execute at some point, so we don't have to put a return statement out.
Mm-hmm. Mm-hmm. So we are quite close. We are quite close. So for positive number, it actually works as expected. But for negative number, it's like almost. So that'll be all for this video. Take care. Bye-bye.